everyone. I'm Sujani, faculty in physics at Institute of Aeronautical Engineering, Hyderabad. Today we are going to discuss the tutorial question bank on module 3 in the course Engineering Physics, that is laser and fiber optics. So let us first look at the short answer questions. So we are going to look at the short answer questions first. The first question is, define spontaneous and stimulated emission processes involved during de-excitation of atoms. So what is a spontaneous emission? An atom which is initially present in the excited state, it makes a transition voluntarily on its own. This term is very important here, voluntarily, without the aid of external stimulus or any other agency, to the ground state. It emits a photon of energy E2 minus E1, and this process we are calling it as spontaneous emission. So where is the atom present? The atom is in the excited state. So we call this is E2 is the excited state. The atom which is in the excited state makes the transition to the ground state on its own without any external stimulus. So then we call it as spontaneous emission. How is the emission occurring? So this is what? Without any aid of external stimulus, on its own, we call it as spontaneous emission. Now after seeing spontaneous emission, we are going to discuss what is stimulated emission and then compare stimulated emission and absorption. So what is stimulated emission? A photon having energy h nu 12 impinges on an atom present in the excited state. So the atom is in the excited state. So a photon is incident on it and it is making it to stimulate, to make a transition to the ground state. And because of this stimulation, it gives off a photon of energy h nu 21. And the emitted photon is in phase with the incident photon and they are coherent. This process we call it as stimulated emission. So let us now go and see the process. So initially, the atom is in the excited state. So this is E2. E2 here is the excited state. So when the atom here is in the excited state, a photon of energy h nu 12 is incident and it is making a transition. It is stimulating the atom in the excited state. So it makes a transition to the ground state. So when it makes a transition, what happens here is energy is emitted. So how is the energy emitted? h nu 21, the difference in energies between the two, and the incident photon. So these two are coherent and we get laser. So this process we call it as stimulated emission. Now coming to the next one, we are going to compare stimulated emission with absorption. So the name absorption itself says that it is going to absorb some energy. So if a photon of energy h nu 12 collides with an atom in the ground state. So where is the atom now? In the ground state. So this is excited with the help of energy by a photon given by h nu 12. And then the atom will absorb the incident photon and makes a transition to the excited state. So this process we are calling it as stimulated absorption. So let us see before absorption. So E1 here is the ground state, E2 is the excited state. The atom is in the ground state. So the atom is here in the ground state. Now when a photon of energy h nu 12, this is the photon of energy h nu 12 is incident, then what happens? It will absorb the energy, and after absorption what happens? The atom will go to the excited state. After absorbing this energy, this is going to the excited state. So because it is absorbing the energy and going to the excited state, we call it as stimulated absorption. Now the next question is define lasing action. What is lasing action? In lasing action, there are 3 steps. One is pumping, where we use the energy to pump the atoms from a lower level to a higher level. And because of pumping, we achieve a condition called population inversion. So population inversion here means always the number of atoms in the excited state is more than that in the ground state. After achieving population inversion, there will be stimulated emission of radiation. So the atoms which are in the excited state are stimulated with the help of an external photon to make the transition. So these are the 3 steps that are involved in the lasing action. Now next we are going to define the terms population and population inversion. So let us understand first what is population. Population here means the number of atoms that are present in a given state. Now if you see generally, the number of atoms in the ground state, if I say this is E1, the ground state, E2, the excited state, N1 is the number of atoms present. So the number of atoms present in the ground state is always more than that in the excited state. So if you see here, you see 5 atoms and here only 1. So N1 is greater than N2. N2 the number of atoms in the excited state. So this is the general scenario which we have. And the atoms that are present in a given state, we are calling it as population. But this condition is not favorable for lasing action. For lasing action, what we want is the number of atoms in the excited state should be more than that in the ground state. So we use some pumping mechanism and we will pump the atoms from the lower energy level to the higher energy level such that the number of atoms in the excited state N2 is greater than N1. So this condition N2 greater than N1 is called population inversion. So the process of making N2 greater than N1 is called population inversion. We are inversing the condition of population. So it is called as population inversion. Next, what are the different types of pumping mechanisms we have? So we have listed at least 5 pumping mechanisms. The first one is optical pumping, where we are using light. And the second one is electric discharge. By supplying a very high voltage, we allow an electric discharge. And with the help of it, there is pumping. Then inelastic collision of atoms. The atoms that are present in the active medium will collide with each other and there exists transfer of energy. Because of that, there is pumping. Then thermal pumping is always related to heat. Thermal, when we say, is related to heat. So because of that also there can be pumping. And then chemical reaction. Whenever there is a chemical reaction between the atoms that are taken in the resonant cavity, we call it as chemical reaction. So these are the different mechanisms we have for pumping. Now coming to the characteristics of laser light. List the characteristics of laser light, or what are the characteristics of laser light. So 4 very important and unique characteristics of laser. First one is highly monochromatic. Highly monochromatic means mono means single, chromatic is always related to the color. So here you have light of single wavelength. Light of single wavelength. Then high degree of coherence. Coherence means they are always in phase. Whatever the radiation that is emitted is in phase. Then high directionality means unidirectional. The light here is not spread in space, but it travels in a given particular direction. So we call it as unidirectional or high directionality. Then high brightness, it is very bright or intense. The laser beam is very intense. So these are the 4 characteristics of laser light which makes it so important and useful. Next, what are the different types of laser? Next is what are the main components of laser, and then we'll discuss about ruby laser. So first to see the different types of laser. So in types, we are classifying, the broad classification will be gas lasers, solid state laser, semiconductor laser, chemical laser and excimer laser. So if you see the examples for gas laser, we have helium neon laser and CO2 laser. And in solid state, we have ruby laser and glass laser. And semiconductor lasers, we have homojunction laser and heterojunction laser. Chemical laser, we have hydrogen fluoride laser, and excimer laser is fluorine laser. So these are the different types of laser we come across. Now, what are the basic parts in a laser system? If you are talking about a laser system, it consists of 3 basic parts, 3 important things. One is the active medium. What is an active medium? An active medium with a suitable set of energy levels to support the laser action. So it should have a set of energy levels, like we were talking about the atoms excited from lower energy level to the higher energy level. So at least there should be 2 energy levels minimum. 3 is always preferred, but minimum 2 energy levels to have the lasing action. And then energy source. What is the energy source for pumping? Pumping here represents the process of sending the atoms from lower energy level to higher energy level in order to get population inversion. So we need an energy source. And the third thing is an optical cavity or a resonator. So this is used to introduce the optical feedback to maintain the gain of the system, overcoming all losses. So with the help of the resonating system, we maintain the gain in the system so that we get the laser. Now coming to ruby laser. So when it comes to ruby laser is a solid laser. So what we are going to discuss is, when we have discussed 3 parts, the active medium, the pumping and the resonating cavity. So what is the active medium in ruby laser? That is what we are going to see now. First thing is, what is the active medium in a ruby laser? So in a ruby laser, that is a single crystal of ruby, if you take, it is aluminum oxide plus chromium, is taken in the form of a cylinder and it acts as a laser medium. So if you see here in the figure, this pink rod, if you see this cylinder there, this is the ruby rod. And the active medium in the ruby laser is made up of a host of sapphire, we call La2O3, that is aluminum oxide, which is doped with small amounts of chromium atoms. That is how we are getting this ruby rod. When we are taking aluminum oxide and doping it with chromium atoms, so we get a ruby rod, and this is the active medium in ruby laser. Now coming to the pump source. So how is pumping happening? How are we supplying the energy for excitation of atoms? So in ruby laser, we use flash tube as the energy source or the pump source. So the flash tube supplies the energy to the laser medium. If you see here, this is the helical lamp which we are using as the flash source. This is the flash source, high intensity flash lamp. So when there are flashes, what happens? Lower energy state electrons in the laser tube gain sufficient energy from the flash tube and then they jump to the higher energy level. So that is what we are calling as pumping. So we are sending the atoms from the lower energy level to the higher energy level. For that we need energy, and the energy source here is the flashlight. So we are calling it as optical pumping. We also call it as optical pumping because we are using light as the source. So the pump source here is the optical pumping. Now coming to the resonant cavity or the optical resonator. So the ends of the rod are flat and parallel. So when we are talking about these ends, these two ends of the rod, this is the cylindrical rod of which it has two flat ends. They are flat, they are parallel. And the ruby rod is placed between two mirrors. And the optical coating is applied to both the mirrors. So there will be a coating to both the mirrors here at the ends. So one is partially reflecting and one is fully reflecting. So that is how we have the optical resonance inside the cavity. Next, list the advantages and disadvantages of a ruby laser. Then we will discuss about helium neon laser and then the merits and demerits of helium neon laser. So first let us see the advantages and disadvantages of ruby laser. So when it comes to advantages, it has a large power output and the pumping efficiencies can be increased by using cylindrical mirrors. So when we are using cylindrical mirrors, the pumping efficiency can be increased and it has a narrow line width. The laser has a narrow line width. What are the disadvantages then? Because it's a 3-level pumping, which we are going to discuss in the next few slides. 3-level pumping, it requires very high pumping power. When we are pumping, it requires a very high pumping power for ruby laser. And the laser output is not continuous. It is in a pulsed mode. Why it is not continuous? Because the pump source we are using here is a flash tube. Whenever there are flashes, the atoms in the lower level absorb the energy and go to the higher level, and it is not a continuous one. So we call it as a pulsed mode. It is not continuous and the efficiency is very less. Now coming to the helium neon laser, we are going to discuss what is the pumping mechanism, what is the active medium, and what about the resonant cavity. So first is the pumping. So we have already seen in ruby laser, we have used the light source for pumping. But in helium neon lasers, light energy is not used. We use a high voltage DC power supply. We are using a high voltage DC power supply. So when we are having this tube, the two ends are connected to a very high voltage DC power, and because of that they get the energy and the atoms get excited to higher states. Then what is the active medium? The active medium is a mixture of helium and neon gas, which is contained in the tube at low pressure. So in this tube, if you see here, the tube, it consists of helium neon gas mixture. That will be the active medium. And it is kept at low pressure. What is the pressure? The partial pressure of helium is 1 millibar and that of neon is 0.1 millibar. We are measuring the pressure in terms of bar. Okay, this is the unit for pressure. So low we keep the pressure, and the gas mixture is mostly comprised of helium gas. And therefore, in order to achieve population inversion, we need to excite primarily the lower energy state electrons of the helium atoms. When we are mixing this gas, we mix it in the ratio of 10:1. Means for 10 atoms of helium, there is 1 atom of neon. So because these are taking active part, what we need to do? We need to excite the helium atoms mainly. Now coming to the resonating cavity. So the glass tube containing a mixture of helium and neon gas is placed between two parallel mirrors. And these mirrors are coated. They are silvered or optically coated. So if you are taking the tube in which we are having the gas, this is placed in between two parallel mirrors and each mirror is silvered differently. One is partially silvered and the other is fully silvered. So the partially silvered mirror will start reflecting and also the fully silvered one, but from the partially silvered one we get the laser out. Now what are the advantages of helium neon laser? So it emits light in the visible portion of the spectrum. So in the visible portion of the spectrum means around 4000 to 7000 angstrom units, we can get this laser. And high stability. Helium neon laser has very high stability and it can be obtained at low cost and it operates without damage at higher temperatures. So you can operate even at higher temperatures without damage. And the main advantage of this gas laser, because when we are talking about helium neon laser, it's a gas laser. A ruby laser, when we compare it with, it is a solid laser. So what is the advantage of gas laser is they are less prone to damage. So they can be run continuously. They cannot be damaged easily due to heating. So we can run these lasers continuously. What are the disadvantages? Disadvantages of helium neon laser. Low efficiency, low gain, and they're also limited to low power tasks. The power output is not high, so we are limiting it to very low power tasks. Now, what are the applications of laser? We are going to discuss the applications of laser in different fields. Since it's a short answer question, we may write one in each field. So the first one is in communication. How laser is used in communication. So it is used in optical fiber communication as a light source to transmit audio, video signals and data to long distances without attenuation and distortion, without the loss of signal or the change in shape or size of the signal. So that is how it is used in communication. Then it is also used in industry. Mainly it is used for welding. When we talk about welding, dissimilar metals can be joined using the laser. That is what we generally see in industry. And then laser in medicine. So it is used in eye surgery, especially to attach the detached retina. So they are using laser beam to do eye surgeries also. So these are the different applications in various fields. Now coming to what is the principle behind propagation of light signal through an optical fiber. So we have come to optical fibers now from lasers. So what is the principle behind here? So the principle here is total internal reflection. Total internal reflection. So what is total internal reflection? When a light ray traveling from an optically denser medium to a rarer medium is incident at an angle greater than the critical angle, then the ray is totally reflected back into the same medium by the laws of reflection, and we call it as total internal reflection. So the principle it follows here is total internal reflection. So what are the conditions for total internal reflection? So the light ray has to come from a denser medium to a rarer medium. This is the first condition. And second thing, it should be incident at an angle greater than the critical angle. Then we have the ray. So if you see in the figure here, the ray that is incident, if it is incident at an angle greater than the critical angle and the refractive index of the core is greater than the cladding, means it is coming from a denser medium to a rarer medium, then it will reflect back. So it will pass only through the fiber and not come out. Now give the expression for numerical aperture. What is the expression for numerical aperture? We should have defined. We are going to define the numerical aperture also. So expression is Na is equal to sine theta naught or sine theta A. Sometimes we write the acceptance angle as theta A. Sine of the acceptance angle gives us the numerical aperture. Or we can also use the formula n1 square minus n2 square power half or under root n1 square minus n2 square. It is the same. N1 and N2 here represent the refractive indices of the core and the cladding. Now discuss the refractive index profile of the step index fiber. So when it comes to fibers, different types of fibers based on the refractive index, we have two types, the step index fiber and the graded index fiber. So here we are going to discuss about step index fiber. What is the step index? In refractive index profile. So let us understand it with the help of this diagram. Now when we are talking about optical fiber, there are different parts, but here the two major things are, one is the core, which is surrounded by the cladding. So this is the core and this is the cladding. Now when I see the refractive index of the core, it is uniform throughout. So I am showing the refractive index profile here. The refractive index of the core is uniform. This. Now when it comes to the interface between the core and the cladding, there is a sudden change in refractive index. So the refractive index varies suddenly. There is a sudden change in the refractive index, and this will be the refractive index of the cladding. So we have kept it symmetrical. So this is the refractive index of the cladding. So this represents the refractive index of the core. There is a sudden change at the interface between the core and the cladding, and this is for the cladding. This is how the refractive index varies. So what we try to understand here is the refractive index of the core is uniform, the cladding is also uniform, and there will be a step change in the refractive index at the interface between core and cladding. That is why we are calling it as step index fiber. Now find the expression for the critical angle in an optical fiber with core refractive index as N1 and cladding refractive index as N2. So let us see the expression. So when we are talking about N1, the refractive index of the core, and N2, the refractive index of the cladding, according to the law of refraction, what we have, N1 sine theta 1 should be equal to N2 sine theta 2. Now when we are talking about critical angle, so the angle at which it is incident. Now if I am talking about a ray of light which is incident, this is incident. This is a denser medium. It is coming from a denser medium to a rarer medium. If the angle of incidence is equal to the critical angle, then the ray will just graze the surface. This is R. And R here is equal to 90. So let our I1 be equal to theta C and our theta 2 will be equal to 90. This is theta 2. This is theta 1 and this is theta 2. N1 sine theta 1, N1 refractive index of the core, N2 refractive index of the cladding. So we are going to substitute these two conditions in this equation. So N1 sine theta C will be equal to N2 sine 90 and sine 90 is 1. And we want theta C. So sine theta C will be N2 by N1 and theta C will be sine inverse of N2 by N1. So this is the expression for critical angle. So whenever you have to find critical angle, it depends upon the refractive indices of the core and the cladding. Now Snell's law. How we are going to use the Snell's law to explain the refraction. So Snell's law is used to determine the amount of refraction that is occurring between two media. So what does Snell's law say? The ratio of the sine of the angle of incidence to the sine of the angle of refraction is always a constant for a given pair of media. So when we are not changing the media, so for a given pair of media, sine I upon sine R is always a constant, and that constant we are calling it as mu. Now here if you are taking these two media, one is the core and the other is the cladding, sine theta 1 upon sine theta 2 will be equal to N2 upon N1. So this is how we are relating it with Snell's law. Next, list the parts which contribute to the structure of an optical fiber with a diagram. So with the help of the diagram, we are going to understand the different parts of an optical fiber. So what is the structure of an optical fiber? If you see, the first one here, what you see here is the glass which may not be visible. So this is the core. So covering the core, we have the cladding, the outer covering. Here is the cladding. and over the cladding we have a coating, and then we have a strength member and then an outer jacket. So this is the outer jacket, this is the strength member, this is the coating, this is the cladding and the core. So for light to pass through the optical fiber, core and cladding are very important. So our focus will be majorly on core and cladding, their diameters as well as their refractive index. So the rest of all are for strength and protection. So we have the core, the cladding, the protective layer, the strength member and the outer jacket. Now the next one, the mechanisms through which attenuation takes place. Attenuation here always represents the loss of signal. There will be absorption losses, scattering losses, bending losses. In bending losses, we have micro bending as well as macro bending or the waveguide losses. So these are the different types of losses due to which there is attenuation in optical fibers. Now one more, define the terms acceptance angle, numerical aperture and acceptance cone for an optical fiber. So we are going to have three definitions. So the first one is acceptance angle. What is acceptance angle? So it is the angle at which the beam has to be launched at one of its ends in order to enable the entire light to propagate through the fiber. So if you see in the diagram here, this is the core. So the light will travel through the core. Of course, this is the cladding. Now, what angle it has to be incident? The light has to be incident for it to propagate through the core. Angle at which the beam has to be launched. So if I am making it incident at an angle greater than this, then it may not pass through the core. So we have the condition also. So acceptance angle here represents the angle at which it has to be launched for the signal to propagate through the fiber. Now comes the numerical aperture. Numerical aperture talks about the light gathering capacity of the fiber, and it is always expressed in terms of the maximum acceptance angle, which we call it as a numerical aperture. So numerical aperture can be represented as sine theta A or theta naught. Because it is acceptance angle, I may write theta A, or in some books the notation used may be sine theta naught, if theta naught is the acceptance angle. So the numerical aperture is the sign of the acceptance angle. Now coming to acceptance cone. What is acceptance cone? How do we get the cone first? So it is a cone obtained by rotating a ray at the end of the phase of the optical fiber around the fiber axis. So here if you see in the figure, this is the axis we consider, optical axis, and at one end we may take a ray. This is the ray. Now I am going to rotate this ray about the axis, then I will get a cone like this. This is the cone we are getting. So light launched at the fiber end within this acceptance cone alone will be accepted and propagated to the other end. So if it is incident outside the cone, then it cannot propagate through the fiber. So acceptance cone, so all the rays that fall inside the cone can easily propagate through the fiber. Now coming to the long answer questions. So for long answer questions, I am not going to give you the complete answer. We are only going to discuss what you have to write. And if you have any doubt regarding the question, you can refer to the video of that particular topic. Okay. So I'll just brief you with the long answer questions and then go forward. So explain the characteristics of laser and the phenomenon of lasing action required for the production of laser light. So all the 4 characteristics you have to mention and explain. 4 characteristics and explain them. Then we have to explain the lasing action. So in lasing action, we have seen 3 steps in lasing action: the pumping, the energy source, and the gain medium. So all the 3 you have to explain in the lasing action. So that is what you are going to write here for characteristics and lasing action. Second question, what do you understand by absorption and pumping mechanism related to the excitation of atoms from lower energy to higher energy? So first thing is you have to explain about absorption. Absorption here means stimulated absorption. We have already discussed stimulated absorption, the process of sending the atoms from lower energy level to higher energy level with the help of some stimulation, with the help of a photon. So we call it as absorption. You have to explain the mechanism because it's a long answer question. Also the diagrams you need to draw. And then the pumping mechanism. So what are the pumping mechanisms we have in excitation? All that you have to discuss. Then explain the terms. Spontaneous emission, stimulated emission, pumping mechanism, stimulated absorption, population inversion. All the 5 we have discussed in short answer. Only thing is here you will have to elaborate and write the answers for long answer. Next, explain in detail how pumping mechanism is done by optical pumping and electric discharge. So here you have to discuss in detail 2 types of pumping. One is the optical pumping and the second one is the electric discharge. So for optical pumping, you can take the example of any one optical pumping, say in ruby laser, how we are doing. In optical pumping, how it happens, how the atoms are excited, how we are providing the light, all that you need to explain. And then electric discharge also you can explain with the help of helium neon laser, how we are connecting it to a high voltage DC supply. So because of that, there will be an electric discharge and the atoms get excited with the energy supplied. Then summarize in detail the working of laser with all its components. So we'll have to summarize the laser, all the components of the laser we have to talk and discuss. So what we have here is the active medium, then we have the resonating system and the pumping mechanism. All we have to discuss here. Then explain in detail 3-level and 4-level laser pumping schemes. So what happens in 3-level, what happens in 4-level, you have to discuss. 3-level means there will be 3 energy levels like we have discussed in Ruby, E1, E2, E3. So the atoms that are excited to this state cannot stay there for a longer time. So they may come here and stay for a longer time. And this will suffice for the condition of stimulated emission because the number of atoms in the excited state is more than that in the ground state. Then we can get stimulated emission. And then 4-level means there may be 4 different levels, 1, 2, 3, 4. Maybe in helium and neon we will see more than 3 energy levels. So whenever we are talking about the levels, if there are 4 levels, how the pumping occurs. So you will have to discuss. Now the next one, explain the construction of ruby laser in detail with the help of a neat, suitable diagram. So first thing is the diagram. The diagram will carry at least 2 marks. After drawing the diagram, you will have to explain the construction. Means each part you will have to label and explain its function. The function of each part. So what is a ruby rod, what it is made up of, what is the shape we take, then what is the pumping source, how do we keep the pumping source, why is it helical, how does we get the flashlight, and how are the resonating cavities, what are the mirrors we are placing them, what is the function of the mirrors. All these things you will have to explain here. Then summarize the construction of helium neon gas laser in detail with the neat diagram. So here also the same thing. They're not asking you to explain the process. Only thing is explain the construction. Here also summarize the construction. If they're asking you to explain the construction and working of helium neon laser, then you will have to explain the energy level diagram also and explain how the laser is emitted. So here it is limited to construction. So first the diagram, labeling different parts, and then explaining different parts and their function. Next one, compare helium neon laser and ruby laser. So how do we compare helium neon laser and ruby laser with different characteristics? What is the type of laser? Starting from, if we are talking about helium neon laser, it's a gas laser. Ruby laser is a solid laser. And then what is the active medium here? So in ruby laser, we are taking the rod, aluminum oxide and chromium mixed, and in helium neon, we are mixing different parts of helium and neon, which serves as active medium. Then the pumping method, if you see here in ruby, it is optical pumping. In helium neon laser, it is electric discharge. And then the optical resonator. What is the optical resonator here? So the ruby rod itself with the mirrors placed in between the mirrors will act as optical resonator. Here the tube in which the gas is filled is placed between two mirrors, which acts as the optical resonator. So all the points you have to discuss one by one with respect to all these characteristics. Then explain the importance of laser in different fields like industry, medicine and science by giving their application. So what is the importance in industry? You may name 2 or 3 applications in industry and explain them. And the same way in medicine also, you can give 2 or 3 and explain their importance with the help of the application. So in science also. So you can discuss the applications. Now coming to optical fibers. What is an optical fiber? Explain its construction and principle with an each diagram. So first you will have to define what an optical fiber is. So the first 1 mark will go for the marking scheme if we talk about the optical fiber definition. Then you explain the construction with the end principle with an each diagram. So the diagram also will carry 1 mark and labeling will carry again 1 mark. Optical fiber definition will carry 1 mark. Then the construction, you have to explain the construction, how the core is taken and what material it should be, what should be the refractive index, what is the condition that we have to manage for construction. All that you have to explain. Maybe construction will be for 2 marks and principle on which it works, total internal reflection. So if you see a 7 mark question, you should also know the marking scheme. So here the definition is for 1 mark. The diagram is for 1 mark and the labeling of different parts is 1 mark. Construction along with their functions. Construction maybe 1 mark. The functions of each part, if you are explaining, you will get 1 mark. And then the diagram for total internal reflection and explaining the principle, you will get 2 marks. So 1, 2, 3, 4, 5, 6, 7. This is how the marks will be divided in the marking scheme. So always you will have to keep in mind when you have a question like this. Next, find an expression for the angle of acceptance or the acceptance angle in terms of refractive indices of the core and the cladding. So we have to find the expression for the acceptance angle. So what is acceptance angle? Theta A. So you will have to get the expression for acceptance angle. Then explain numerical aperture and derive an expression for numerical aperture. First you will have to define what is numerical aperture and explain why numerical aperture is very important. And then you will have to derive the expression for numerical aperture. NA is equal to sine theta A. And then substitute the values and also you will have to find it in terms of n1 square minus n2 square upon n0. So how we are getting this expression? All the steps you need to explain in detail while deriving. Next, explain in detail different types of optical fiber based on refractive index profile. So when we are classifying, we classify them based on the type of material that is used, We classify based on the mode of propagation and also on the refractive index. So here the question is refractive index. So based on the refractive index, we have seen two types. One is the step index and the other one is the graded index. So explain both in detail because it's a long answer question. You will have to explain both in detail with the help of the refractive index profile diagram, how it is varying. Next, draw the block diagram of fiber optic communication and explain the functions of each block. So the entire fiber optic communication system we'll have to explain with the help of a diagram. So if you see the major parts, there will be a transmitter, there will be a receiver, and there will be an optical fiber through which the signals will pass. So if you see the major parts, then in transmitter there are different parts and in receiver you have different parts, how the signal is being transmitted. So the entire block diagram, you can refer to the video on block diagram on optical fiber communication. You can find the video and then understand how to explain that. Then coming to advantages of optical fiber communication. So what are the advantages of optical fibers in communication? So you can list down at least 5 to 6 important advantages of optical fibers because it is fast, speedy communication and also it is reliable. There is no interference, no loss of signal, less weight and low cost. All these will form the advantages of optical fibers in communication. Next, explain in detail different types of optical fiber based on mode of propagation. See here, we are talking about the classification based on mode of propagation. So when it comes to mode of propagation, we have single mode propagation and we also have multi-mode propagation. So when will the signal travel in a single mode? When will it travel in multi-mode? So what are the conditions for single mode? In single mode, the diameter of the core is very small. How will be the diameters? What should be the ratio of the diameters to core and cladding? Draw the diagrams and explain. And for multi-mode, the diameter of the core is large. So again, you will have to draw the diagram and explain what should be the ratio and what is the form in which they travel. In single mode, it always travels in a straight line. In multi-mode, it may travel in a zigzag manner. So all these things have to be explained for different modes of propagation. Next, explain different types of attenuation in optical fiber. So here you will have to list different types of attenuation. Means different types of losses. We are talking about the scattering loss, the Rayleigh loss or the bending losses. And in bending there is further we have the micro bending and the macro bending. All the types of losses which amount to attenuation you will have to discuss one by one and explain because it's a long answer question. You will have to explain each type of loss. Next, compare step index and graded index fiber. What are the differences between the two? So you'll have to first talk in terms of the refractive index profile and list the differences between them. So in step index, how the refractive index varies. So in graded index, how it varies at the core cladding interface. In step index, the refractive index is uniform throughout. Whereas in graded index fiber, the refractive index varies from the core, the center to the surface. It keeps on varying. And what are the advantages also comes in the differences here. Then summarize different applications of optical fibers, where all we are going to use optical fibers in different fields. You can give at least two applications in various fields. I think with this we complete the long answer questions and now we'll move on to the analytical questions. So in analytical questions, we have questions on laser as well as optical fiber. So the first one is calculate the wavelength of emitted radiation from a semiconductor diode laser which has a band gap of 1.44 electron volt. So here again, I'm not deriving or the whole thing, or I'm not solving all the numericals. Only thing is I'll be giving you the outline. You can refer to the video on numericals and then learn the numericals if you want. Here I'll just give you the formula and the approach of how to do the analytical questions. So the first one, if you see, first we have to take the data given. What is the data given? The band gap is given. It is given in electron volts. You'll have to convert it into joules. How do you convert it? 1 electron volt is 1.6 into 10 power minus 19 joules. And then you have to use the appropriate formula. We know E is equal to h nu, or it can be written as hc by lambda. We have to find the wavelength. So from this, we are going to write the formula for wavelength lambda as hc upon E. We are just transposing, you get lambda is equal to hc upon E. H is a constant, C is a constant, the velocity of light. H is a constant. You may have to remember the values if it is not given in the data. And E here is the energy gap which is given. We have converted into joules. Now let us just do the substitution H, C and E. You will get the answer. We are converting it into angstrom also because generally the wavelength is expressed in angstrom units. 1 angstrom is 10 power minus 10 meters. So you can convert it also and express. Now coming to the second one. A semiconductor diode laser has a wavelength of 1.55 micrometer. Find the band gap. So in the previous one, the band gap is given. We had to find the wavelength. Here the wavelength is given and we will be finding the band gap. So let us write the wavelength in the given data and convert it into meters. Because it's given in micrometer, 1 micrometer is 10 power minus 6 meter. So H we have and C we have. So E is equal to H nu or Hc by lambda. It is mere substitution. H, C and lambda in meters. So you will get the energy. We are getting the energy in joules. If we want to convert it in electron volt, we'll have to divide it with 1.6 into 10 power minus 19 because 1 electron volt is 1.6 into 10 power minus 19 joules. That is why we are going to divide it with 1.6 into 10 power minus 19 and write the answer in electron volt. Now the third one. Calculate the wavelength of the emitted radiation which has a band gap of 1.68 electron volt. So here the band gap is given in electron volt. We have to find the wavelength similar to the first one. So let us see, the energy is given. We are first doing the conversion to joules, taking the value of H which is a constant, C is also a constant, and we have to find lambda. So directly we'll use Hc upon E and do the substitution. This is H, this is C and this is E. So upon substitution what we are getting here is 7.39 into 10 power minus 7 or 7390 angstroms. Now coming to the fourth one. So here a semiconductor diode laser has a wavelength of 1.42. You have to find the band gap in electron volt. So again write the wavelength, convert it into meters, take the value of H and C and write the formula for E, Hc by lambda, do the substitution and simplify. So any numerical you have, it consists of 4 major steps. The first step is writing the given data and doing the conversion. Second step is writing the formula or deducing the appropriate formula, and then substitution. You will have to substitute the values correctly in the given formula, and then you will have to simplify. You have to simplify or calculate. You may use a calculator, but you will have to simplify and write the answer in the required units. That is the 4 steps we are following. Now the next one, calculate the refractive index of core and cladding of an optical fiber with a numerical aperture of 0.33 and their fractional differences of refractive index as 0.02. So you have to find the refractive index of core and cladding. Numerical aperture is given and the refractive index change is given. So let us see how we are going to approach it. So if you see the data, so the data here is NA, numerical aperture, and the refractive index change. So we are going to use the formula NA is equal to N1 under root 2 delta. We have to find N1, the refractive index of the core. So how do we get N1 from here? So when you square on both sides, what you will have is N1 square will be equal to NA square upon 2 delta. So if you want N1, take the square root. So NA upon under root 2 delta. So NA is given, delta is given. We can easily get N1. Once we get N1, we can easily get N2 because we know NA is equal to under root N1 square minus N2 square. So N2 will be equal to what? First square and then take the terms onto the other side. N2 will be equal to what? N1 square minus NA square under. So we have got N1 here. We will substitute for N1 and NA is given. So we will substitute NA and get the answer. So N2 here is equal to 1.5. So this is the refractive index of the cladding. This is the refractive index of the core. Next one, step index fiber has a numerical aperture of 0.16 and the core refractive index is 1.45. You have to calculate the acceptance angle and the refractive index of the cladding. So we are going to use the formula theta A is equal to sine inverse of NA. Because NA is given, first we will be finding the acceptance angle. So NA is given 0.16. So get the acceptance angle because we have to calculate the acceptance angle. After getting the acceptance angle, we are going to find the refractive index of the cladding. Generally, for the core, we represent it by N1 and for the cladding, we represent it by N2. So the formula we have is NA is equal to under root N1 square minus N2 square. Because we want N2, the refractive index of the cladding, we are rearranging the terms and getting the formula for N2. So N1 square minus NA square means we are writing it in known terms. We know N1 and A also we know. So it is mere substitution and simplification. You get the refractive index of the cladding. Next to the seventh one, refractive index of the core and cladding materials of a step index fiber are 1.48 and 1.41. Means this will be for the core, this will be for the cladding. What you have to calculate? Calculate the numerical aperture and acceptance angle. So both are given, so it's a direct formula. So NA will be equal to N1 square minus N2 square. So here what we can do, if we have to calculate NA will be under root N1 square minus N2 square. What is our N1? Refractive index of the core 1.48 whole square minus N2 1.45 whole square. Simplify, you get the answer. Then how do we get the acceptance angle? So acceptance angle theta A will be sine inverse of NA. So you will get the acceptance angle. Now the eighth one, optical fiber has a numerical aperture of 0.02 and cladding refractive index, that is N2 1.59. Find the acceptance angle for water which has a refractive index of 1.33. So we are not placing it in air now, we are placing the optical fiber in water, so whose refractive index is 1.33. So how do we do it? The formula we are going to take is, this is actually the generalized formula. NA is equal to under root N1 square minus N2 square upon N0. If N0 is equal to 1 for air. For air, what do we take? N0, the refractive index is 1. So we will simply neglect the value of N0 and we are writing under root N1 square minus N2 square. But here it is mentioned it is in water and the refractive index of water is given. So now what we are going to do, we know the numerical aperture 0.2, that is under root N1 square minus N2 square, upon N0 is 1.33. So simply substitute the values and you get the answer for NA. Here what you need to understand is the concept, how the formula varies when it is placed in water and how do we do the substitution. So once you get NA, you can easily get the acceptance angle. Sine inverse of NA will give us the acceptance angle. Let us see two more form problems. Calculate the fractional refractive index change of an optical fiber if the refractive indices of the core and the cladding are given. N1 and N2 are given. So what is the formula for fractional change in refractive index? It's a simple formula, delta is equal to N1 minus N2 by N1. N1 is given, N2 is given. So N1 minus N2 upon N1 gives us delta. This is the fractional change in refractive index. Then the last one. When the mean optical power launched into an 8 kilometer length of fiber is 120 microwatts, the mean optical fiber output is 3 microwatt. Find the overall signal attenuation and the signal attenuation per kilometer. This is what you have to find. So what is the formula for signal attenuation? Alpha L will be equal to 10 log to the base 10 Pi upon P naught. So Pi here represents the power input and P naught represents the power output. So power output is given, power input is also given. So first let us substitute here and get the value of alpha L. So alpha L will be equal to what? 10 log 10, 120 into 10 power minus 6 because it is given in micrometer. So 1 micrometer is 10 power minus 6 meter. So we are going to substitute here 10 power minus 6. We are writing it in meter. Upon 3 into 10 power minus 6. So 10 power minus 6, 10 power minus 6 cancels. 120 upon 3 gives us 40. So 10 log to the base 10 40 will give us 16 decibels. dB here represents decibel. Now because we are writing the formula alpha L is equal to 16 decibel, we want alpha. So alpha will be 16 upon L. What is the value of L given? The length of the optical fiber is 8. So L is equal to 8. So 16 upon 8. So we get it in decibel per kilometer. So what is the attenuation per kilometer is 2 dB per kilometers. So let us stop here and thank you and see you again in the next lecture.
Like, share and subscribe. Hit the bell icon for more updates.